So question 13, what we've got is a boat, and the boat is stationary. When the boat is stationary, one thing that we know is that the forces are balanced on it. So it says complete the free body diagram for the boat. What we mean by free body diagram is this entire boat is now represented by a dot right there. Okay, so we know that there is a downward force on the boat, which is the weight, and because the boat is floating, there is an upward force in the opposite direction called upthrust. Now, here the question is complete the force uh, free body diagram for the boat, and we know that the forces are balanced, so we need to put an arrow on this diagram which is equal in size to the weight and in the opposite direction. And what we should do as good practice is label that as well as the type of force as upthrust. Okay, and because the boat is floating and the weight is equal to the upthrust and it's stationary, so these two forces are equal and opposite. You need a ruler to draw this, and you need to make sure that it is equal in size to this opposite force here. Now, the next part is calculate the mass of the boat. Now, to calculate the mass of the boat, they've given you the gravitational field strength, and this diagram, it shows you that it's to scale. So that means every 1 centimeter is worth 5 kilonewtons. So when we measure from here to here, we notice that it is 5 centimeters long. So that's five lots of 5 kilonewtons, and as a result, that's 25 kilonewtons or 25,000 newtons. Okay, so when we're using this formula here of mass is equal to weight over gravity, and this is the weight mass gravity formula rearranged for mass, we must use weight in newtons. So that 25 kilonewtons that we measured out here, 5 centimeters, each centimeter is 5 kilonewtons, 25 kilonewtons, 25,000 newtons. We put 25,000 newtons as a weight, divided by 9.81, and the mass is 2,548 kilograms. Now, it says give your answer to three significant figures. That's four significant figures, so I'm going to round it to three, so it's 2,550. 1 mark for finding this force here, 25,000 newtons from the scale. 1 mark for this rearrangement, 1 mark for this answer, and 1 mark for the answer rounded up. So the force of the water causes an equal and opposite force to act on the boat. Which law is this an example of? It's Newton's laws, and it is the third law in specific, where every action has an equal and opposite reaction. Part D. Now, this boat is being pulled by this rope. Sorry, this boat is being pulled by this rope, by this larger boat here. So the tension force in the tow rope is in this direction. So you can clearly see it's a slight angle the rope is at. Now, the horizontal force on that rope is 150 newtons, and the vertical force on that rope is 50 newtons. Now, using these two, we can find out what the tension is inside that particular rope. So we have to draw a scale diagram. We've got to pick a scale. So I'm going to pick 1 centimeter is equal to 10 newtons. That means 150 newtons will be 15 centimeters, and 50 newtons will be 5 centimeters. So what I'm going to do is I'm going to draw an arrow horizontally 15 centimeters long, which I've done here. And I'm going to draw an arrow from the same point 5 centimeters vertically, straight up here. Now, once I've done that, I am then going to create a parallelogram. So this line here is parallel to this force arrow, and this line here is parallel to this force arrow here. And where those two parallel lines cross, that is the point where the resultant force acts, i.e. the tension. So we draw a line from the object, which was here in this position, to where the lines intersect, and that gives me the resultant force, the tension on that particular rope. If we measure that out, that would be 15.8 centimeters, and due to that scale, that's 158 newtons. The angle that we get is around about 18 degrees. So 158, and what was accepted was between 155 and 160, and 18 degrees, so what was accepted was between 18 and 20 degrees.